Hello, dear students. Once again, I am here, Lalit Kumar P. Bhaiya, Associate Professor, Electronics and Telecommunication Engineering Department, Bharati College of Engineering and Technology, Durg. Today we will discuss about the remaining part of the diode. This is last article of the diode. Later on we will go for the transistors and other parts or rectifiers using the diodes, that we will see the applications of the diode. And this is my 8th video now. Till now we have gone through the total 7 video according to the syllabus step by step. This is my 8th video which will be on the topic of diode. I will speedily go to the slide which I want to show you now. Whatever we have seen, that I am showing you. These diodes we have already gone. The formation of depletion region, defining depletion region, applications, and this topic we have already studied. Biasing of diode, forward bias, reverse bias, these we have already seen. Bulk resistance of the diode, reverse biasing resistance, that we have seen, and ideal diode, that we have seen, and the forward bias and diode reverse bias, bulk resistance, these articles which we have already seen. Now today we will go through the VI characteristics of the diode and temperature dependence of VI characteristics. This is, you can see here, this is the VI characteristic. Here in vertical axis the current is there, which is in terms of milliamperes, and here the voltage. For silicon diode this knee voltage is 0.7 volt, and for germanium diode it may be a 0.3 volt. This is called as forward current, and this is called as a reverse current. This is in reverse bias condition. Negative of the diode is connected to the positive of the battery, and positive of the diode is connected to the negative of the battery, that is reverse bias. And here positive is connected to the positive, negative is connected to the negative. This is forward bias. So we will get this forward bias characteristics here, and this is reverse bias characteristics. This is called as a breakdown, from where this current suddenly falls down in reverse bias is called as a breakdown. This is called as breakdown voltage. Here it is written as breakdown voltage, VZK, or VB, you can write anything, that doesn't matter. This is breakdown voltage, and this is the reverse condition, and this is the forward condition, and this voltage is called as the knee voltage. Knee voltage, here negative current, here positive current. So this current is called as the reverse saturation current, and this current flows on in case of the only reverse bias diode. And the very important is this diode current equation, which is specially given by current flowing through the diode is equal to I naught into exponential e to the power V by Vt minus 1, where I naught is the reverse saturation current in reverse bias and I is the forward current. So this is the relation between this diode current and voltage. This V is the voltage applying to the diode, Vt is the temperature equivalent of the diode, temperature, junction temperature voltage, I is the forward current, and I naught is the reverse saturation current. Above equation is further simplified, modified. We can write in place of Vt, we will write the neta Vt. So this is very important and very popular diode equation. This characteristics can be shown using this equation. This is called as characteristic equation of the diode. I is equal to I naught into in bracket e to the power V by neta Vt minus 1. E to the power V by neta Vt, then minus 1 below, where n is equal to 1 for germanium and 2 for silicon. This value of n is constant. This is fixed. So this is the very popular characteristic equation of the diode. Now here What is this cut in voltage? I have already told you in characteristics. You can see this voltage is called as cut in voltage, where the current suddenly increases in forward bias. This is called as cut in voltage. In forward bias condition, as long as the voltage is less than the barrier potential, very small or almost no current flows, the voltage after which the current increases rapidly is called cut in voltage. Its value is 0.2 or 0.3 for germanium and 0.6 or 0.7 for silicon. You can see this diagram. This is called as cut in voltage. Below this cut in voltage, there is a very small current flows in the forward direction, but after just crossing this cut in voltage, the rapidly increase in current is there. So this is called as the cut in voltage in the diode that we have already seen. Now, what is the temperature dependency of the VI characteristics? It is also very important. Reverse saturation current. It is well known that reverse saturation current, that is in terms of I naught here, I naught. This I naught is a temperature dependent characteristics. Reverse saturation current, which is a very temperature dependent. It doubles for every 10 degree rise in temperature. In case of the PN junction, in reverse bias condition, this reverse saturation current flows. This reverse saturation current I naught flows, and this I naught is having the property, it doubles for every 10 degree rise in temperature, junction temperature. If the junction temperature increases by 10 degree, this I naught will be double. In case of the transistor, this I naught is represented by ICO, that is collector to emitter with base is open. This reverse saturation current gets doubles for every 10 degree rise in temperature. And now this relation is given by this I naught is equal to I naught 1 into 2 into T minus T1 by 10. This is the temperature dependence, and forward voltage decreases at the rate of 2.5 millivolt per degree Celsius. So this forward voltage also decreases at the rate of 2.5 millivolt per degree Celsius. That is dV by dt is equal to minus 2.5 millivolt per degree. This is the temperature dependent. And Vt is always equivalent voltage of the junction temperature is junction voltage is equal to Vt. And this Vt will be equal to, it is Kt by Q, where K is the Boltzmann constant, T is the temperature in degree Kelvin, and Q is the charge of the electron. Similarly, this if we put the value of K and if we put the value of Q, this Vt can be calculated as T by 11,600. So these three characteristics shown here. One is the reverse saturation current that doubles for every 10 degree rise in temperature. Second is the forward voltage.